All right, welcome to your notes. This is for Honors Pre-Calc. These notes really encompass both sections 7.1 and 7.2. But today, instead of focusing on linear functions, we are going to focus our attention on nonlinear functions. The methods that we are using for nonlinear functions are exactly the same, which is why we were reviewing linear functions yesterday. So this is what takes us from working in the realm of Algebra 1 to taking us into Pre-Calc. Nonlinear functions, think of all of the types of functions and families of functions that we worked with after basically chapter 1. You could see parabolas, you could see trig functions, you could see exponentials, logarithms, polynomials of higher degree, all of those kinds of functions combined also with linear functions. The methodology is the same. So we've got graphical solving, we've got substitutions. What usually happens is that your solutions can be just a little bit more complicated, and in fact, you can end up with multiple solutions. So let's work on the graphical version first. It's a great review for your families of functions. Next year, if you're moving on to calculus, you need to have a really strong hold on all types of functions. You should be able to look at this particular function and decide for yourself rather quickly how you would graph each of them. For example, I want to look at the top line and notice that this is a linear function. And then I want to remember how to graph linear functions. You have a lot of choices. The way that I've rewritten this, I would probably use the mx plus b form, right? You've got a y-intercept at 3, and you've got a slope of 1. So up 1 over 1, up 1 over 1, and I could continue that pattern. Let me find my ruler really quick because, again, the graphical method is really only as good as your graph. So I want to try to make it as exact as possible. That's going to get a little harder with my next piece, right? I need to be able to look at the second equation and know for sure that it is a parabola, and I need to remember how to graph parabolas. You have a lot of choices. You could turn this thing into vertex form with complete the square. I like just sort of that standard version that you probably learned in Algebra 1. We're going to find our vertex first, so negative b over 2a. In this problem, that's 4 over 2 or 2. And if I plug 2 into my equation, then I'll get 4 minus 8 plus 7. So what does that come out to? 3. So my vertex is at 2, 3. Let's see, 1, 2, 1, 2, 3. Right? I know it's opening upwards. I'm just going to pick a couple of points to determine exactly how this thing opens up. So if we're sitting at x equals 2, then let's kind of go 1 in each direction. If we let x equals 1, then y would be equal to 1 squared minus 4 times 1 plus 7. So what would I get? Minus 3 plus 7, I'm going to be at 4. And so 1, 2, 3, 4, it just so happens, right, that I've crossed right there. And I could even use symmetry to notice that it's going to open up at x equals 3 to that same height. So I could sketch in my graph. So here's a perfect example of how sometimes solving graphically can be a bit tricky. It's pretty clear, just the way that I got lucky and guessed another point, that they're going to intersect at the coordinate 1, 4. I can see it, right? A really good idea on these is to follow up with just a quick check, right? 1 minus 4 is negative 3. Negative 3 plus 3 is 0. And then I could double check down here, which I really just did, and I could see that they both share that point in common. It's a little bit harder to identify that point. I've tried my best here, but of course it's not coming out perfectly. It looks like it's around 4, and then 1, 2, 3, 4, 5, 6, 7. So it looks like 4, 7, but I would want to go ahead again and double check. 4 minus 7 is negative 3 plus 3. And again, if I plug into here, what would I get? 16. 16 minus 16 is 0 plus 7. So 4, 7 is accurate. If you had maybe read it as 5, 7 or something, you'd want to make sure that you did that space of checking, right? That extra step to make sure that you had solved it correctly. Your graph is really only as good as your scale, and here I don't have a perfect scale. So graphing is obviously an option, and there'll probably be one on your quiz where you need to graph it. A lot of students ask, can I also solve it another way to make sure that I got the right answer? Absolutely. Or you can do like I just did and just double check your solutions. Our next piece that we want to move on to would be solving using substitution. So this one is set up perfectly, right? They're both equal to y. I don't know if you remember transitive property from your days in geometry, but if two functions are equal to y, then they are equal to each other. You're essentially swapping out the y, substituting out. So x cubed minus 3x squared plus 4 should also be equal to minus 2x plus 4. Right? I'm substituting in one y for the other, or you can think of it as they're both equal to y, so they're both equal to each other. This one's set up perfectly for substitution. We're going to drag everything over to the left. Really, anything squares and higher, we need to set equal to 0. So we're going to have x cubed minus 3x squared plus 2x when I pull it to the other side. And now I get sort of lucky here. It could have been a lot harder to factor, but when I subtract 4 over to the left, I'll end up zeroing out. And then I want to remember all my tools for solving equations. Right here I need to factor. We have an x in common. And then I'll go ahead and factor that interior piece, right? I'm going to have an x times an x to make an x squared. And I want to multiply to positive 2, add to negative 3. So minus 2 and minus 1. So what are we going to have? X equals 0, 2, and 1. That alone is not my solution, right? I need to go back and I need to find the coordinates. When we're talking about solving systems, we are talking about finding points of intersection. The biggest difference between just solving linear functions and solving functions that are nonlinear is the fact that you are very likely to end up with multiple solutions, right? Yesterday, or whichever day, depending on when you're watching, we were talking about linear, and really 2 lines can only cross either at one point or not at all, right? Or maybe they're the same. With a parabola and a line, you could get 1 point or 2 points. Here we've got a cubic function and a linear function, and we've got 3 coordinates. So it must be looking something maybe like this if we were to graph it out. So we want to go ahead and plug in. You can choose whichever one you like. I would plug into the simpler function. So let's plug each x into that second function. We'll get 0, 4. Right? If I plug in a 2, I'll get a 0. And if I plug in a 1, I'll get negative 2 plus 4, I'll get a 2. So those 3 coordinates are the solutions to my system. We'll finish the backside in video 2. So take a break here and we'll flip it over.